So let's look at Python next. So we are going to use Python in our exploit development section. And again, I am going to give you Python scripts or skeletons, so all you'll have to do is work on the actual exploit string. You won't have to worry about like setting up a network socket in Python and things like that. But I do encourage you to learn it. Python is used a lot in information security. We like our Python. We also use Ruby a lot. And so knowing one or both of those would definitely be worthwhile. Go ahead and stop this. So let's open up another one here. So I'm going to call this one, let's see, let's call it pythonscript.py, or we can just call it python.py. And again, we want to give it an interpreter. This is going to be an interpreted language as opposed to compiled. And the last thing we'll do is C, which is compiled. So for this one, we just need to give it an interpreter. As long as the system has a Python interpreter, which chances are if it's a Linux system it does, then it will be able to run this. So we want hash bang bin, and in this case it is, where is Python? I think it's just bin Python. No, maybe not. Let's see. Let's go ahead and kill this. So let's do which Python. User bin Python. So we didn't see the which command previously, but for cases like these where I'm just not sure where it is, it may be in different places, we can use which Python, and that will tell me that it's at user bin Python. That's where my Python interpreter is. So nano python.py hash bang user bin Python. Glad I looked that up because I had the wrong answer there. Alright, so this time we're going to do a basic little port scanner. Very basic. We'll see some much more intelligent port scanners when we move into port scanning later in the course. We'll look at kind of a basic, simple example here. So what we're going to do is see whether a port is open or closed. So we talked briefly about ports, and I mentioned I once had a boss who thought ports were actually those slots on the back of the machine, which certainly wouldn't go very far with our small machines we have today. In fact, your phone has the ability to make TCP/IP sockets using ports, so that would certainly make for a big phone. So they are just going to be network sockets. We make them with pieces of code just like this, in fact. So a typical exercise in programming, and certainly one you could try if you want to continue and learn some more, is to set up a simple web server in your programming language of choice, so be it in C, Python, even, we're not going to do a Ruby example here. We will see a little bit of Ruby in the exploit development, but it is, I think I had to do it in school. It was like make it serve a web page, make it serve a JPEG, make it serve a GIF, things like that. So you set up a listening socket and serve pages, so a little bit more advanced than what we're doing here, but that would be a good next exercise. So let's go ahead and set up a little port scanner here. So this time we're going to take some user input not from the command line. So in the last one we had a command line argument. You can do that here in Python as well, of course, but this time we're going to do things a little bit differently. We're going to take input from the user just with a prompt. The first thing I want to do is import a library. We didn't have to do that with our bash script, but basically what we want to do is say import and tell it we want the socket library. So that way we don't have to do all the underlying code of how to set up a network socket for our port scanning. There's already a library in Python that knows how to do this. We can use that as a building block to make our lives much easier. So we always want to use stuff that we can rather than reinventing the wheel, because otherwise we'd be here all day for sure, particularly as beginning programmers. Alright, so now we want to do a variable. We haven't seen a variable yet. Basically what we want to do is have a variable of whatever name we want and set it equal to a value. So it's basically a way to store data. So let's just call it IP. It is going to be the IP address, so that's a good name. So I'm going to create the variable called IP and set it equal to something called raw underscore input. Again, that's a Python construct. You can Google it to find out more about it, but it's just going to take input from the user. And I'm going to tell the user, enter the IP address. So when this runs, it will prompt the user, enter the IP address, and whatever they respond with will be stored in that IP variable. So by storing it in the variable, we'll be able to use it later in the program. And let's also do port. So we want an IP address and port. So another variable called port. Set it equal to. This time we're just going to do input. We want port to be a number, and then IP address is actually going to be a string. That's just how the connection works. And so we'll just do enter the port number. And then we have a socket. Let's not do the socket just yet. Let's do that next. Let's actually see this run first. Let's not get ahead of ourselves. So again, we want to do our chmod. This time let's do +x. Python.py. Run python.py. This time we don't need a command line argument. It does ask us for the IP address. I'll give it the IP address of my Windows XP system, 76, and port is 80. Well, that's all it does at this point. So it does prompt us, and it is going to store those two values for us. Alright, so now let's set up the socket. So, again, we have that socket library, so we can look up how to do this. This is one of those things that if you don't use it a lot, you'll probably have to look it up. So I'm just going to set sock, so another variable. So sock equals socket.socket. Yeah, because that totally makes sense. Parentheses socket.af underscore inet. So this is going to be a TCP socket. You can also make UDP sockets. One of our exploits in exploit development will actually be over the UDP protocols. So it'll actually be trivial FTP, so UDP port 69 rather. So we will see how to make a UDP socket as well. It's just a little bit different. So that is our syntax right there. And again, don't feel bad if you have to look that up unless you're doing a lot of Python programming. I mean, even if you take a break from it, you may have to look that up. So now we want an if statement here as well. So just like we did in the bash script, except the syntax is going to be a little bit different. I think a lot easier to work with. I don't think the syntax in bash scripting is that intuitive, whereas Python is a bit more intuitive, I think. But really it's a personal preference, what programming languages you like the best. Everybody seems to have their own opinion. So in this one we just do if, and we don't need any braces or anything. So if sock.connect. So I would think it's .connect. Typically we do use .connect. There actually is another option. So if we look at Python connect underscore ex. Here's some Python documentation about socket, exactly what we're after. So we looked at connect. So this is the typical construct that's used for connecting. So connect to the socket to a remote address. For IP sockets, the address is a pair host port. Right under it, we have connect underscore ex, which is the one I mentioned. It's like connect, but it returns an error code instead of raising an exception when an error occurs. So if it isn't able to connect, connect will actually throw an error, so we would have to handle the exception, or else the program would crash, and that's not good. But with connect underscore ex, it looks like it'll throw an error code, so it won't do an unhandled exception. We won't have to do any error handling. it'll just give us a specific error code. So if our goal is to see whether or not the port is open, these error codes might be ideal rather than crashing it with connect. So let's try connect_ex. If sock.connect_ex, and we want to give it with double parentheses around it, IP and port. Remember, we asked the user for IP and port. We're giving it the IP address and port to connect to. We want a colon, so that's going to be our if statement. And what's interesting about Python is that it actually takes indentation as law. It actually denotes loops with indentation. So as long as we are indented, this would be part of our if statement. This, however, that's not indented would not. Of course, both of those are rubbish and not real commands, but you've got to be careful with your indentation. But it also makes it pretty easy to read. You can really tell where your loops are with the indentation, but you just can't get off with your indentation or else you'll have a mess on your hands. So if the connection works, so if it's true, which true is going to be anything non-zero, so any error code that we get is going to be true. So if it's true, I want to print out port, and port is closed. So what is this here? So we're going to print out to the screen, print the word port. This has quotations around it, so that's going to be a literally string port. Then we tell it we want port. Remember, port is a variable, so it's going to take the value of port, and then it's going to print out is closed. So if we do get a positive error value, that means the connection was not successful, so that port is closed. So we're going to print out that port is closed. Alright. We also have an else statement here, and again we want colon to denote the beginning of our ifs and else statements here. And again, indentation matters. We need to indent. We need to make sure our else is right against column 0, but we do want to indent the else. So if we get a 0 back instead of a positive value, we want to print out port is open. So pretty primitive, it only takes one port and checks whether it's open or closed. Certainly we'll see we can do much better, but it's something. It's a good little exercise. Now let's run it. IP address 192.168.1.76 in my case, and port 80. It says port 80 is open. Run it again. Port 81. Port 81 is closed, so it looks like my Windows XP system has something listening on port 80. Perhaps a web server. 80 is typically where web servers listen, but nothing on port 81. I can't think of anything in particular that listens on port 81, so that's not too surprising. Again, a little simple example here. Not too much going on, so I encourage you to spend more time with Python as well. Again, we'll see Python when we get to our exploit development. And some of the tools we'll look at have been written in Python. It is a pretty big language for information security. Alright, so last little bit on programming, and then we'll actually move on to pen testing, what we're here for. We are going to look very, very briefly at the C programming language. Hopefully not too many security tools are written in C, but your operating systems, a lot of them are written in C. So, like your Linux is written in C, Windows does a lot of stuff in C, like your Android is all in C, iPhone is too, honestly. Well, the underlying system is anyway, some of it. So you've got a lot of C out there in terms of like the platforms you're going to run into. Unfortunately, C is one of those ones, and it does have a tendency to have security issues with memory corruption based on some sloppy programming. So I guess that's good for us bug hunter types. Let's look very briefly at C, but again, I don't encourage you to use C to actually write your security tools, but more power to you if you actually do. We'll see that it's a little bit more complicated. So I'm just going to call this, how about C program.c. So this is going to be compiled. C is a compiled language, so we don't have to do our hash bang up here. We're going to compile it with a compiler. So what I want to do is actually do the equivalent of my import statement in Python. I want to do hash include and stdio, so standard IO, so standard input output .h. This is just a header file, so this is like our library that we brought in with our Python. We have standard input output. We don't have to reinvent the wheel here. We're just going to do possibly the most basic C program ever. We're going to basically do hello world with a twist. So in C, we have to do things as functions. With our scripting languages, we just, wrote things one after another and everything was dandy. It's going to be a little bit different here. We do need to do functions, and there's a function called main in every C program that is the main function, as the name implies, and it is going to be run when the program starts. So we do int main, so that's going to return an integer. There's other types of functions, certainly, like void returns nothing, string returns a string, things like that. So int main, and to take user input, int arg c. So that's the argument count, and this is just standard C stuff. You can look it up if you don't remember it. So argument count, and then you basically pass it a character array of the command line arguments. So again, that's just standard. So we are going to take command line arguments for this, as opposed to asking the user, which you could do that as well. So in our bash script, we took a command line argument. In our Python script, we took input from the user by prompting them during the program. With this one, we are going to take command line arguments, but you could just as easily prompt the user. Alright, so in C, to denote our functions and loops and things, we use brackets, or, well, curly braces, I guess is what they're technically called. So we're opening up this int main, and we can also go ahead and close it and work between these. It's good practice to do indentation, but C doesn't take the indentation as fact. As long as you have your braces, you're good. This is just, good programming style. Let's do an if statement again. So once again, have to be different among our programming languages. So the correct syntax here is open parentheses, and then what we want to test. So I want to test whether the length, so the argument count, is less than 2. So with C, our first argument is going to be the program name itself, and then the second argument will be our first user command line argument. So if the argument count is less than 2, in other words, if the user does not supply a command line argument, again, we can put some help information in there. Again, we need our curly braces around our code that's going to be run as part of the if statement. And again, the indentation is not actually going to be interpreted by the program. It's just good practice, makes it easier to read. Use a function called printf. Printf may be subject to some security issues. You might want to look up that if you're interested about format string issues. So we're going to do something that looks a little funny here. So in parentheses we have %s and then \n. \n actually means new line, and our %s is actually a placeholder for a string. We want a comma, and then we want the string, so pass your name as an argument. So this is going to print out the string to the console if, and only if, the argument count is less than 2, so the user doesn't provide a command line argument. Just like our help information that we used in our bash script, if they didn't use the program correctly, we showed them how. So this time we once again give help information. Pass your name as an argument. But if they do give us a command line argument, we don't run that if statement. So we instead do an else. And else we don't have to do an argument here, so we don't need that. But we do need our parentheses. Actually, if it's one line only, you can do it without the parentheses, but I can't keep the little tricks straight for all of the different languages, so I just basically stick to the basics of syntax. There's always little tricks you can do with all the languages, but there's so many. So this time, again, I want to do that printf. Again, there might be some things you can do with printf from a security perspective. Again, I want to give it a string and then a new line. So I want to say hello, string, new line. And the string I want to give it is argv. Remember, argv is our character array of our arguments. So I'm going to tell it I want 1. So remember 0 in our array. So the first command line argument will be the program name itself. So argv1 is going to be our first command line argument. So make sure we've got all of our parentheses. So curly braces, parentheses, you know what I mean. Every time we open one, we need to have them closed. That makes the indentation work really well because we can kind of see if we end up back here at the base at the end, then we're good. So since this is an integer, so it's going to return an integer, we actually need to have it return something. So let's do if argv less than 2. So this is an error, so let's have it return -1, so it failed. But if it works, let's return 0. So it passed. That isn't completely necessary. I mean, the main thing with the functions is that we call a function and it returns something that we're able to pass back to other functions. So we don't have to do everything all in one little script. We can have different functions that we can pass different inputs. We don't have to keep writing the same code over and over. So a little bit more of a complex construct of how to do programming, but it's definitely a best practice and not one I always follow, so take my lead. Alright, so we can't just run cprogram.c even if we do a chmod on it, because C is, again, compiled, so we are going to have to use a C compiler for this. So luckily there is a C compiler included in most Linux distributions. GCC, the GNU C compiler. So we want cprogram.c, and we can do -o for output, so we can name it something in particular, so we can call it cprogram. If we don't do that, then it'll just call it a.out, which it'll still run, so a.out is fine, but we can name it something with -o. I got an error. What did I do wrong? Expected semicolon before return. What have I forgotten? Another thing that's complicated about C is that it has semicolons in it, which I started out in C, so I was good at my semicolons, but now I've used Python and Ruby so much that sometimes I forget my semicolons. Sure enough, we need a semicolon right here. Forgot one. Let's try it again. No error that time. Looks good to me. Alright, chmod plus x, cprogram, run cprogram, pass your name as an argument, Georgia. Hello, Georgia. So, probably the second simplest program, because typically you do hello world and then something like this where you give it your name. But we did something a little bit simpler with C, which I realize may give you the impression that C is not as powerful as some of the other languages. That's not true at all. I just think it's a little bit more complicated with all the braces and the semicolons and the functions and things like that. We will return to C briefly in the exploit development, but I mean, keep in mind that the entire Linux operating system is written in C, so it's certainly powerful. It does all that. So it's not any less powerful. I just think it's a little more complicated, but it's certainly worth knowing because, again, so much stuff is written in C. You'll probably, if you continue, find yourself working with some C code, trying to find bugs in it, things like that. So it's certainly worth knowing the basics of as many programming languages as you can, but I would say getting really familiar with at least one language and having kind of a working knowledge where you can, with the help of Google, pull in all the right syntax of other languages is definitely helpful. I mean, the more, the better. So, again, just kind of a short overview here. Certainly can't make you a programming expert in, 48 minutes, but hopefully it can lead you on that path, and if you like it, I certainly encourage you to continue. Alright, so let's actually start pen testing now. So now we're going to take a look at a tool called Metasploit, which is a pretty awesome pen testing tool, and then we'll start actually attacking our systems. So you're about to get your first shell on a target.